Welcome back to the channel, and I'm Ryan from Edusama, and we are going to dive into chapter 3 chemistry. So from the last chapter, we've left off on the experiment to determine the empirical formula. So we can summarize the whole thing to molecular formula is basically empirical formula, but the empirical formula should be brackets with n. The number of empirical formula is equal to the molecular formula. Now, let me give you an example. The empirical formula for a certain substance is CH2. The molar mass for this specific substance is 56. So, how do you determine the molecular formula for this specific substance? First, you calculate the molar mass for the empirical formula first. So, CH2 is carbon is 12, hydrogen is 1. So 12 plus 1 plus 1 is 14. So you take the 56, you divide it by 14, and you should get 4. So the 4, as I mentioned just now, the summarized molecular formula and empirical formula is just brackets. So you put CH2 brackets, and the number here is 4. 4 in number. Now you multiply this into the empirical formula. So originally C is 0 so you multiply by 4. C4 H2 multiplied by 4 is 8. So it's C2H8. This is the molecular formula for the substance in this question. Now, it's the third subtopic for this chapter 3 is chemical formulas. A lot of people have a lot of issues with this chapter because they didn't memorize any charges or oxidation states. I'll explain later, I will understand later. So, let's dive into it. Now, it's chemical formulas for ionic compounds. Ionic compounds don't have empirical formula because ionic compound is, they don't repeat themselves. They are just normal one-to-one compounds already. They do not repeat themselves, not like organic substances. Okay? So, ionic compound is made out of ions, negative ions and positive ions. Because, as you know, positive attracted to negative, negative attracted to positive. And if they are the same charges, they will repel. So, very easy. Ionic compounds is always 100% is made out of 2 ions, as the name implies, ionic compounds. Remember this, very easy one. So, cation is positive, anion is negative. Let me teach you how to remember. Does your cat bring joy to you? Is it positive? Yes, it's a positive energy. So your cation is positive, while anion is negative. There's no cat. To determine the ionic compound of a certain substance is way easier if you just memorize the table. The common ones is very easy to memorize. I can't emphasize this enough. Even until Form 5, there are students who haven't memorized this and they are in a very deep shit. So please memorize your ionic compounds, oxidation state. That is a compulsory. Or else just do more exercise and you eventually get it. Okay? So the common ones are sodium, potassium. They have a positive oxidation state of positive 1. Positive 1. Sodium and potassium. Positive 1. For aluminium, he is always the exception. He has a charge of positive 3. We are going to talk about cation first, then we'll go into negative ions, okay? Zinc and magnesium. For zinc and magnesium, they have a charge for positive 2. Yes, they have positive 2. For iron and copper, they have different oxidation states because they are in the transition metals. So, this you'll learn in the later chapter, but remember that iron and copper has different oxidation state. And this, very important, you need to write down the oxidation state in the chemical formula. So you use Roman numbers. Iron has 2 possible charges, positive 2 and positive 3. So label iron 2 oxide and iron 3 oxide. Both of them have different numbers of oxygen and iron. So remember to label properly when you're writing iron oxide or anything that involves iron or copper. This is the characteristics of transition elements. So beware and be wary. For copper, is copper 1 or copper 2. Next is calcium. Calcium is positive 2. Lead is also a transition element, so it also have multiple oxidation state. So remember to label it properly also. The oxidation state for lead, for what you are reading right now, is lead 2. Now ammonium and ammonium. Ammonium is an ion. Ammonia is not an ion, because just take a look at this. Ammonium is, nium has NiUm, which is four numbers. For the ammonium is NH4. So the extra hydrogen makes it so it becomes an ion. This you will ask, why the extra hydrogen one? This you will learn in the future chapter. As I said just now, ammonia is not an ion because ammonia has 3. Nia has Nia. Nia has 3, so NH3. It doesn't have any charges. That's it for cations. Go to your textbook and just memorize the table, or you just do more questions already can one. So now let's talk about anions. Anions are negative ions. So the most common one you must 100% know one. Oxygen. Oxygen O has a charge of negative 2. Chlorine also very easy one. This one also must know. Chlorine is negative 1. Bromide and chlorine is the same. Iodine is also the same. Oxide ion OH, this one actually don't need to memorize, but you see oxygen is 2 negative. Hydrogen is positive 1. So if you just do simple math, negative 2 plus 1 is equal to negative 1. Oxide ions are negative 1. Carbonate ions is 2 negative. Carbonate ions is CO3. For nitrate ion is NO3. Has a charge of negative 1, same as chlorine. Next is phosphate. Phosphate is very not common one, so it's negative 3. It has a molecular formula of PO4. PO4. Sulfate just now is SO4. Thiosulfate is also very not quite common. S2O3. Thiosulfate is S2O3. Has a charge of 2 negative. Dichromate ion has a charge of 2 negative. So it's Cr2O7. So now let's dive into how do you determine the molecular formula for the ionic compound. For ionic compounds, they must end up as neutral, meaning that for example zinc oxide. Zinc has an oxidation state of positive 2. Oxygen has a negative 2. So they have the same charge already. So if you add them together, it's already 0. This is just taking a very easy example. But what if you take something like aluminium oxide? Aluminium has a charge of positive 3 and oxygen is 2. It doesn't really quite make sense. So for one of the method you can do is they call it like a cross-hatching method. So you just take the number of charge for aluminum is 3, just put it down to oxide, the oxygen there, and the 2 to the aluminium is Al2O3. So you see aluminium 2 has in total of 6 positive charge, while oxygen has a total of negative 6 charge. So you ended up as a 0 as well. So now talking about naming the compounds, there's 2 systems. One is IUPAC, is the official one according to the World Chemistry Organization one, IUPAC one. The next one is you play long put one, cannot like this. Better you use IUPAC. Okay, so you might ask from the ions just now, chloride ions. People ask, why not chlorine ion? Why must chloride ion? Because this is according to the IUPAC system. So if they become an ion, they might add IDE behind to the original name. For chlorine, they add IDE, chloride ion. For bromine, also IDE, very easy. Now you see IDE is for elements, whereas ATE is for ions that have oxygen in it. So for example, table salt, NaCl. NaCl is sodium chloride. Sodium chloride, very easy. Sodium is one, chlorine is also one, a negative one. So they combine also neutral. I'll give you more example like zinc bromide and magnesium nitrate. Oh, you see, very they have IDE and ATE, very easy one. So for transition elements, so when they have a multiple oxidation states, how do you differentiate between iron oxide and iron oxide? You can't know. So they have Roman numericals, just like everything inside. They really like Romans, so they just add Roman numerals into the chemical formula. So for iron oxide, iron, you must put iron 2 oxide and iron 3 oxide. Iron 2 oxide is FeO. You see, very easy, FeO, because 2 plus and 2 negative equal to 0. Whereas iron 3 oxide is different. It has the same charge as aluminium. So you can use the cross-hatching method from just now. So it's Fe2O3. Copper is also the same case. Remember to write the Roman numerical thing there for transition element. Lead also need to write, don't play at you. Okay, there's also, you also heard before, carbon monoxide, carbon dioxide, even sulfur trioxide. You see, the mono, di and tri is the number of oxygen, very easy. You see, carbon monoxide is CO, mono is 1, di is 2, tri is 3, tetra is 4, and pen is 5, hexa is 6, and HEPD is 7. This is like the hexagon, polygon, those kind of naming scheme. You see, very quite similar one. They also remember to do some questions in the comment section. I already prepared some questions for you guys to practice, and you know how to do already, then very easy.